Hello friends, very good morning. Myself Dr. M.H. Annaya, and in today's video we are going to work out a problem on the development of a funnel. Friends, for the videos videos of today, we have a problem like this. A funnel tapers from 60 mm diameter to 30 mm diameter over a length of 50 mm, and from 30 mm to 20 mm over a length of 70 mm, and he is asking us to draw the development. Friends, you must have seen a funnel. A funnel will have a circular end like this, and here this is connected to the bottom by another piece. It could be a cylindrical or it could be tapered. So, and here at the bottom is beveled up at some angle. He has given you the diameter at the top. This is 60 mm dia, and this is diameter is 30 mm. The length they have given you. Then from here to here they have given the length as 70 mm, and this is 50 mm. He is asking us to draw the development. How means how the sheet metal is to be cut so as to get a shape like this. So friends, for the given dimension, let us write down the top and front views of this funnel. Friends, the top view will be two circles, one of diameter that is 60 mm and other is of diameter 30 mm. So I'll write down the front view like this. This is the top part, which is cylindrical in nature, and again it is tapering down further from there to over a length of 70 mm. They have given this length as 70 mm. So you have to read the problem carefully and get the values of all these recorded. This is 50 mm, and the diameters at these two ends are. This is having a diameter 560. It's tapering from 60 mm. So maximum diameter at the top is 60 mm, and it is tapering down to this value, that is equal to 30 mm, and he has given the length over which it is tapering from 60 mm to 30 mm. That is over a length. Again from 30 mm it is tapering down to a diameter of 20 mm. So if you mark the center line here, so the value here it will be 30 mm. So we will mark it as 20. And at the bottom it is beveled off or chopped off at an angle of 40 degrees to the horizontal. So mark it as 40 degrees. Friend, this is how the funnel looks in the front view. Now basically friend, we have got two components. One is this upper part and this is the second part. So friends, we will take down these two pieces separately and draw the development. Friends, now I will make the development for the part 1. Part 1. Let's see how does it look. So instead of keeping this frame, we can just keep it inverted and you will get the part 1 like this. So here it has got diameter 30, 530, and this is 560, and friends, this is cylindrical in nature, the conical in nature, sorry, and this is having 50 mm height. Friends, we have studied the development of the cones cut by horizontal section plane. Here friends, if you take this, we already worked out in some of the videos how to obtain the development of a cone cut by a horizontal section plane, and this is nothing but the frustum of a cone because it is cut by horizontal section plane. So friends, I can take this line, the top line, as a section plane SS, and this is the base of the solid. That's the funnel we got here. Friends, now what do? We just mark the center line of this and extend both the sides. These lost generators, you will extend them and see what do we get. So friend, this is the cone of diameter 60 millimeter. It is cut by the horizontal section plane. Friends, very obviously, this is the radius of the base R1, and after extending this center line up to here, we will get O, the vertex, and this will be the length of the generator, which is true in length. This is the length of the generator R, which is a true length. Friends, for this cone cut by horizontal section plane, we have to calculate this theta 1, the angle subtended at the center. That is, O theta 1 is equal to R1 by R1 multiplied by 360 degree. So what is this R1? R1 is the radius of the base. Diameter is 60 by 2. So I will say R1 is equal to diameter by 2, that is equal to 60 by 2, and this works out to 30 mm. Friend, what is this capital R1? Capital R1 is the true length of the generator. So this can be measured after construction of this front view. So R1 obtained from front view, obtained from front view of the figure. From this front view, we can obtain what is R1. That is nothing but the true length of it. Friends, if you substitute in the formula, you get theta 1 is equal to, this is R1. R1 is equal to how much? This R1 is equal to 30, and capital R1 can be obtained from the figure, hence theta 1 can be calculated. Friends, see, we forgot a value, and friends, after calculating the value of this theta 1, let us complete the development of this part. Friends, I just write a line, vertical line of length is equal to R1, and here I mark that angle which is theta 1. This is O, the vertex, and this is R, that is the true length, and this length is also R, that is R1 we have marked. Friends, this is the base. Afterwards, friends, you know, the section plane here, it is cutting all the generators. Even if you have got 8 generators, it will cut all the generators, and we have worked out already, friends. All these are being cut at the same height from the base. So friends, you can take this length, say length OK, this length, and draw an arc keeping center O and radius equal to OK. Friends, I will just take this as the center and radius equal to this OK. I am going to draw an arc. So this part I have completed. Then the base of this solid, that is the funnel, is this part. And friends, if you complete this, this will give you the development of part 1. This is part 1, and I will say here development of part 1, that is the funnel part, upper part. Friends, here you need not divide this circle into number of parts, not necessary, because we know very well this arc length here is equal to OK. I will call this point as K. OK, OK. With this center we have drawn this. This is how we get the development for the part 1 of the funnel. Next friends, after getting this development, let us move on to the second part, that is the tapering part of this. So friends, I will just write down this also again in the inverted form. So this I am going to keep inverted. So we have this length, that is 30 mm. Center line we will mark and take the height equal to 70 mm. This is 70 millimeter height. And this is having a diameter equal to 30. I will say 530, indicating the diameter. And friends, here this being tapered down to 20 at the other end. So at this point, the diameter is becoming equal to 20. So I will take 10 on either side of it, and I am going to join this like this to this. So friends, we have the second part drawn here, and in this second part we have drawn, and the question is says the bottom of this is beveled off at an angle of 40 degrees to the horizontal. So friends, here this part which has got a diameter of 20 millimeter is chopped off at an angle of 40 degrees to the horizontal. You can take it like this. This is how section plane 2-2 is cutting this solid, and you would like to have the development for this part of the solid. That is, this is the section plane. S2, S2, we are going to throw away this part and we are going to write the development for this part number 2. I will say here part 2 of funnel. So friends, it's once again you can just observe this total figure is the frustum of a cone. It's a truncated frustum of a cone. Now friends, to obtain the development, we need to have the diameter or the radius of the base and also this diameter there. So what do we do now friends? We will extend the center line such that these two end generators, so I will say I will just extend this, and I just extend this last line, and these two meet here friends. So we can assume the cone being cut by a section plane at an angle of 40 degrees here, and we need the development of this part. For this friends, I will write down the top view of this. The top view of the base is going to be a circle of diameter 30 mm, and we will divide this circle into 8 equal parts and number them as A, B, C, D, E, F, G and H, and we will transfer all these points to this in the front view. So friends, we will extend all these lines, extend this or join this point to the vertex or the apex. Again this is joined, again this we have to join. So friends, we have joined all these. This is the vertex O. This point is A dash, this is E dash, center is C dash, G dash, and this is B and H, B dash, H dash. Like this you obtain D and F on this. So friends, now after construction of this figure, this length of this last line is the true length of the generator. So we will just mark it as R2. R2 is the true length of generator. So friends, once you have this R2, you will be able to find out what is theta 2, the angle subtended by that part of the funnel. So friends, you write the formula theta 2, the subtended angle is R2 by R2, capital R2 multiplied by 360 degrees. Friends, this R2 is the diameter of the base. This is 30 by 2. So this is 30 by 2. That works out to 15 mm. And this capital R2 is the length of this generator. We will say this as O dash E dash is equal to, so this can be measured from front view. After obtaining this O, you will just measure, keep the scale and measure that length. Hence you can obtain, friends, theta 2, which is equal to 15 by R2. R2 value you have obtained multiplied by 360, you will get the value of theta 2. Friends, once you got theta 2, you will have to obtain the development of this part 2. Let's see how to obtain the development. Friends, here you can see, I will just write a line, a vertical line of length is equal to R2, which is also the true length. This is our O, this O dash. So from here, I am going to draw this another R2 at an angle of theta 2, and then going to join this by an arc, this part. Now friends, if it were a horizontal section plane, I would have taken that distance and written an arc. But now, the second part is cut by a section plane S2, which is at an angle to the axis, that is inclined to the horizontal. So friends, what I do, I divide this segment or this arc into number of parts the base of the circle is divided. The base of the circle is divided into 8 parts. So also, I am going to divide this into 8 equal parts. So we are dividing into 4 parts. Further, we will bisect all these and obtain 8 parts. Friends, this is the base. The base is this one. And friends, here you can see all the 8 generators of the cone are cut by the section plane S2. We will take these generators one by one and mark the point where the section plane is cutting the respective generators. Friends, I will start with this. So before that, let me mark this as A, B, C, D, E, F, G, H, and again A. All these two lengths are the same. They are obtained from this figure, as you can see here. And friends, now if you consider this generator O dash A dash, it is cut here. And you see in the top view, this OA is parallel to VP. Hence, this gives you the true length R2. So now I can mark this distance on OA from O. Okay, I will mark it here. This is point on OA. Okay, I will mark this as point 1. Next friends, this OB and OH are cut here. OB and OH are not true length. We can shift the true length line, the last line, and mark that distance on OB and OH. OB and OH, little above. Next friends, you have got the generators OC and OG, these two cut here. OC and OG are vertical, they do not represent the true length, Hence, I am going to shift that to the last line and take that measurement and mark on OC and OG. You have got these points. Next comes friends. This is generator OF and OD. OF and OD are cut here. So we will mark this on the true length line, obtain that on OD and OF. OD and OF. Friends, finally, the end generator O dash E dash is cut here. O dash E dash is the true length because OE is parallel to BP. I will take that point on this OE. So AA we have taken on BB, CCDD, E, and 2, 3, 4, 5, 6, 7, 8. And this we are going to take it on OE. OE, this point is there. So friends, OE I should take. So friends, we have got all the points where the section plane is cutting the slant generators, now the generators, and I am going to join all these points by a smooth continuous curve. So friends, this is how it is being cut, and here the base is intact, that is A full. This is the base, and the portion on OA till here at the bottom to be retained, and friends, all these construction lines are to be retained, and do not show them by thick lines or visible lines because they are all generators which are assumed to exist. And friends, this will give you the development of part 2. Development of part 2. Friends, this is how we obtain the development of a circular funnel. Friends, in some of the problems in this second part, instead of giving the tapered part, the second tapered part, they may also give you a funnel like this, that is circular here, and this bottom portion they may give it as a cylindrical piece, again chopped off at some angle. And here the development of this we know very well, that is a frustum of a cone, and here it becomes a development for a cylinder which will be something like this. So this we not make again as a separate problem, and if you know how to make the development for the first part, that is the frustum of a cone, and this is the frustum, it's not frustum, it is a cylinder cut by a section plane inclined HP, you will be able to complete the problem. Friends, I hope the presentation was interesting and you find it useful to you. Do subscribe to my channel and share this information with all your friends. Have a good day. Thank you very much.